Let us have a quick review to the introduction to set theory. So we're going to go through the types of sets, and then we'll spend time on set operations and practice questions. So my intention here, this is just a quick review. So you can check out the other detailed video where we talked about these in detail when we introduced mathematics. Yeah, so you can check out the video on introduction to mathematics. So let's quickly run through. So on the types of sets, we have a lot of them. So like starting with finite and infinite set. So when we say a set is finite, it means the number of items which are in that set. Or I didn't even introduce what a set is. So a set is just a collection of objects. It is a collection of things. We have a set of people, we have a set of animals, and then in mathematics we have different sets of numbers. Yeah, so now when we talk about a finite set, it is a set in which you can count the items which are there. So like if this is a set, it has A, B, C, D. Then we can count the number of items in there are 4. And I have to introduce to you this term. So this is cardinality. So cardinality, the symbol is N. So cardinality simply means how many items are in a particular set. So for example, if set A is equal to A, B, C, D, E. So then the cardinality, we say N of A. The cardinality of set A is how many things are in A? 1, 2, 3, 4, 5. So the cardinality of set A is 5. Yeah, so finite sets have cardinalities, meaning you can count the number of things in that set. Yeah, so now let's talk about an infinite set. It's coming from the word infinity, meaning it goes on and on. So for example, if set A, it is the set of stars. Are you sure you can count the number of stars? No. So this is an infinite set. If we say set A is 1, 2, 3, 4, blah blah blah. So here this is showing you that the set is going on and on, so it is infinity. So the cardinality of a set which is infinite, it doesn't exist. It doesn't exist. Oh, but I don't exist. Yeah, so the cardinality of an infinite set really doesn't exist. Because you can't manage to count the number of stars. If the numbers are going on and on, you can't manage to count them. And yeah, so infinite sets like the set of stars, the sets of stones in the earth. Yeah. So quickly, let's go to an empty set. An empty set is simply a set which is empty. Just from the word. Yeah, if a set has nothing, then it is an empty set. So this is a symbol, or it is written like this. So when you see this, it means it's an empty set. So the other name for an empty set is null or void. These are the other names of an empty set. A null set or a void set. So this is very important. I even put a star in the document to show you that later on when you do this laws of set algebra, we'll have to remember that. And then a singleton set is just a set which is single, like most of you. If a set just has 2, then it's a singleton set. If it just has like A, then it is a singleton. It just has one thing. Quickly, we look at a subset. A subset, it is a set within a set. So like let's say set A, it is 1, 2, 3. Set B, it is 1, 2, 3, 4, 5. So here you can see that all the elements which are in A, they are also in B. So A is a subset of B. Yeah, so this is the symbol for subset. And then for a superset, so I like giving this example when I'm teaching. Like if we have a boy called John and there's another small boy called Martin. If we say John is older than Martin. If John is older than Martin, in grade 12 they would ask you rewrite beginning with Martin. You can't say Martin is older than John, then you are not okay in the head. So John is older than Martin. So if we start with Martin, we'll say Martin is smaller, or we can say younger. So Martin is younger than John. So they're just the same things, but we change. So it is the same with subsets. A subset, when we say A is a subset of B, meaning it is found in B. So we can also write B is a superset of A. So a subset simply means that everything in A is found in B. Like you can see 1, 2, 3, also here we have 1, 2, 3. That is a subset. Or we can say superset. Yeah, so this is not really important. I won't spend so much time here. So meaning that B has everything which is in A. Yeah, so we bounce. So now let's talk about equal and equivalent sets. Equal sets, these are sets which are equal. So like if set A is 1, 2, 3 and set B is 1, 2, 3. 1, 2, 3. So you can see that A is equal to B. No thinking here. Or you can also say B is equal to A because they are the same things. And then now, so that is a equal set. And then equivalent, it means like in B we have A, B, C. So here you can see that the number of items in A, the cardinality is 3. We have 3 items. Also in B, when we count the number of things, we have 3. That is the cardinality. So since A and B have the same cardinality, we say they are equivalent. So equivalent, the symbol is written like this. A is equivalent to B. Yeah. So if they have the same things, then A is equal to B. Good, we proceed. Proper subset. Should I talk about this also? Okay, quickly. So a proper subset, so we can use the same example previously. So here is where we have, we'll use that one on top. So when we have a situation like this, A is 1, 2, 3, also B is 1, 2, 3. We can also say that A is a subset of B because the things in A, they're also found in B. So A is a subset of B. But in a case whereby in B, we have like 1, 2, 3, it's ending up to 4. So if there's something in B which is not in A, we can say A is a proper subset of B. Yeah, so the difference here is that how you write A is a subset of B. You write A is a subset of B, is a subset or equal to B. Because you saw that A was 1, 2, 3, also B was 1, 2, 3. So meaning everything in A is also in B, meaning it is a subset. And then since they have the same number of things, you also put equal to. Yeah, so but when you don't put equal to down there, if you don't put an equal sign here, it means there are some things in B which are not in A. So this is a proper subset. No time wasting here. But if you have questions, you can start with a detailed video and then you comment on this video if you need more explanation, or you just inbox me on WhatsApp. Disjoint sets. These are sets with no common things. So if we have set A, yeah, we'll just keep on using this. So if we have set A is equal to 1, 2, 3, set B is equal to 4, 7, 9. In such a case, there's nothing common between A and B. So we say A and B are disjoint sets. I've forgotten the symbol for disjoint sets. Yeah, but their intersection is empty. They don't have something in common, meaning they are disjoint. So this is very important. Disjoint sets will come again in laws of set algebra. The universal set, you know. Class of sets. Class of sets, this is what by set A is complicated, like mathematicians here. So set A is having 1, 2, 3 in brackets, comma. Again we have 1, 5, 8. So you can see that in set A we have a smaller set and another smaller set. So these are classes of sets. So this is a class, yeah, classes of sets. Yeah, so I didn't have any plans of talking much about this. Yeah, so now we're even proceeding. I wanted to skip. So when you read the Megaminds documents, you won't even find the definitions. Yeah, so set operations. This is where my interest is. So let us quickly discuss set operations. So we have 3 set operations. Okay, so we have talked about types of sets, and then now let's go to set operations. So we have 3 set operations. We have the intersection, we have the union, and we have the complement. So the intersection, it means the things which are common in 2 or more sets. The union means everything in that set. Yeah. And then the complement means excluding some elements. Yeah, so we're going to talk about each one of these. So we're even starting with an example. Just know intersection means the common items, union means everything, complement means excluding. So let's pick up this question from the Megaminds document. You will also find this question in the lecture slides. So I'm not even going to answer everything. You understand. So we have the universal set. So I didn't explain anything on the universal set. The universal set simply means everything altogether. The symbol can be E or capital letter U. That's the universal set. So we have the universal set, it is from 0 to 15. And then set A, it is 0, 2, 4, 6, 8, 12. B, blah, blah, blah. C is that. Find these. Before we even go to those, let us do those basic set operations. If they say find A intersection B, they mean what are the common things in A and B. So here, what can you see? What can you see is common? You can see 0 is common, 6 is common in both, and 12. Yeah, so you only write the things which are common, you write them only once. So you say A intersection B is equal to 0, 6, 12. So you don't write like you write 6 2 times. You just write once. Yeah, so that is the intersection. I'm sure you've perfectly understood. Let's jump. A union B. So as a union means let's come together. So A union B. So by the way, when you Google the word marriage, when you Google marriage or you try to look it up, you find that they say marriage is the union between male and female according to the Bible. So the union between male and female, that is marriage, they become one. So even in sets, from now on I'll be saying the marriage. So A union B means we have Uncle A marrying Auntie B. So just combine everything in A and B. So in A we have, we just write everything. Yeah, so here we write everything in A and B. So we have 0. So let's move this. So we have 0, we have 0, we have 2, we have 3, we have 4. So we write them in order. Do we have 5 in A or B? We don't have 5. Okay, we move. We have 6. So we can see that 6 is found in both. Just write it once. And then the next number we have 10. We're just writing everything. We have 12 up to 15. That is union, A union B. We're so clear there. Questions? No. So you can find A union C. You just marry them. You just marry them and then you write everything. So now questions cannot be easy, like they tell you to find B intersection C. Then that is not mlongoshe. So at least things will look like this. They will be a bit complicated at least. So let's answer question 1. They are saying we find A intersection B union C. So when there are more than 2 things, you always start with what's in the brackets. So let us deal with B union C. So we're going to bring down A intersection. So what is B union C? We just list everything in B and in C. So what can you see in B and C? We have 0, we have 1, we have 2 in C, so we write it, 3, and then 4 we have it, 5, 6, 7, 12, 15. These are the things which are found in B and C. Have you seen how we've written? We've just brought down this and then we find the answer for B union C. Yeah. So now we have dealt with the brackets. So now let's do this and that. So here it simply means A intersection or this. So remember, intersection means what are the common things. So the common things in A and this. So if you want, you can first write what is in A. Yeah, so we're going to write just for explanation purposes. So in A we have 0, 2, 4, 6, 10, 12. Intersection B union C, it is 0, 1, 2, 3. Counting is hard. I remember when we used to play hide and seek, I used to count 1, 2, 3, 10. I go and find the people. Yeah, so this is A. So this is A. This is B union C. So what are the common things which you can see? You can see 0, you can see 2, 4 is common, 6 is common, 10 is not common, 12 is common. We're done. So the answer is 0, 2, 4, 6, 12. You should have answered like that. So we proceed. So now, which one can I answer? So answer more. There are a lot of questions, don't worry, we'll answer them in the WhatsApp group for tuitions. So okay, this one, it's a baby question. By now you can even answer it with your brain shut down. So you bring down what's outside. B union. Let us find A intersection C. What are the things in A they are also in C. So if you look there, the things common, you can see we have what's common. We have 2, 4 is common in both, and 6 is common. These are the only things common. Yeah, so now let's write what is in B. B has 0, 3, 0, 3, 6, 12, 15. Union. Yeah, so that is the symbol between union. Union 2, 4, 6. So if this was intersection, we just pick what's common. But since it's union, we marry them. Yeah, let's make them one union. So the final answer will be, you sort them out from smallest. 0, we shouldn't write 3, we have a 2. 0, 2, 3, do we have a 4? Yes. Do we have a 5? No. 6, 12, 15. So usually when I'm explaining, I'm very slow. I feel uncomfortable when I feel like I'm too fast. I always want everyone to learn. Yeah, so I found the answer just like that. Don't worry if I've rubbed quickly. You can just replay the video again. A union B complement. Complement means complications. So let us find B complement. Yeah, I didn't talk much about the complement. So remember, I said complement means excluding those things. Excluding those things. So the universal set is right there. 1 up to 15, 0 up to 15. 0, 1, 2, 3, 4, 5, 6. 9. Will I finish? 10. Where? I wish I could just pick and then it's written on its own. So this is the universal set. So when we say B complement, it means excluding the things which are in B. Are you getting it? Excluding the things which are in B. So when you look at the universal set, you pick everything in the universal set except the things which are in B. So like we can first write B. What is B? B is 0, 3, 6, 12, 15. So this is B. So now when we say B complement, it means everything in the universal set except the things in B. So B complement will mean we have 0 is in B, we will not write it. We don't want B. 1 is not in B, okay. So these are the things in B complement. 2 is not in B, 3 is in B, 4 is not, 5 is not, 6 is in B, we don't want it. 7, 8, 9, 10, 11, 13, up to 14. Yeah, so what we have basically done, we've said we write B and then from the universal set we remove the things which are in B. Yeah. So yeah, so this is B complement. Yeah, so now from here, so here, in case you are wondering like what just happened, we want to marry A union B. So here we want to find A union B complement. So for A, we already know, we'll just list this. But for B complement, we needed to find it. We only have B, meaning B complement is everything in the universal except B. Yeah, so in the document, I explained it in quite a different way. We were cancelling. So you should ensure to check out the document and see which one is easier for you to understand. Yeah, and if you don't get it, you can always let me know. I'll look for another way of explaining. So let us list A. A is 0, A is 0, 2, 4, 6, 10, 12. Okay, so union, this will go a long way. So so this is our A, union B complement. So B complement, it is this which we saw here. Yeah, so we just bring it here. So just rub it a little bit here. So so this is B complement, the things which are not in B. Yeah, so union means we marry them all together. We're going to marry everything in A and in B complement. Yeah, so the final answer will be, you always start from the smallest. 0, 1, we have a 2, we don't have a 3 anywhere. 4, 5, 6, 7, after 7 it's 10, we don't have 8. Oh, we have 8. So we have 8, 9, 10. So ensure to counter check your work. Mistakes are common, even from the professionals, your lecturers themselves. Yeah, so this is the complement. You just list this and then you have to calculate that. Yeah, so now can we do another one? I'm tired now. Yeah, so you have gotten the picture. We have more examples. You should check out more videos. I've answered the number of them. So here, A intersection C complement, very interesting. A intersection C complement. So I said you start with, you basically start with what's in the brackets. So let us list A intersection C. What things can you see which are in A and C? So I know you guys are smart. You can just pick from here, like you just check. But for beginners, let us just write them. First, let us write A. What is in A? 0, 2, 4, 6, 10, 12. Intersection C. C, it is 1 up to 7. 1, 2, 3, 4, 5, 6, 6, 7. Yeah, and then from here we just pick what's common, meaning what we are finding here, we are finding A intersection C. Yeah, so what is common? We have 2 is common, 4 is common, and 6. That's all. So to find complement now, the complement of this, it simply means we list everything in the universal and then excluding. Complement means excluding 2, 4, 6. So meaning the final answer will be everything here excluding 2, 4, 6. That's the complement. Oh, so here you can do the same. So like, let me give you even an exercise. So try finding this one. Try finding B intersection C, and then we have a complement there. So you can try out that one. So so these are some practice questions. So we have also this tutorial sheet which we are going to handle. Yeah, so I think not in this video, so you should look out for the other video where we do this, and then also in other lessons we are going to do laws of set algebra where we understand all these. Yeah, so for now we'll end here. Our lessons will continue. So this was just an introduction. I hope you found this helpful.